A resolution derivation of a clause phi from a set delta of clauses is a sequence of clauses terminating in phi in which each item is a member of delta or the result of applying resolution to earlier items. We define a resolution proof to be a derivation of the empty clause from the clausal form of the premises and the negation of the desired conclusion. And we say that a sentence phi is provable from a set of sentences delta by resolution, if and only if there's a derivation of the empty clause from the clausal form of delta together with not phi. As an example of using Heilbronn resolution to determine logical entailment, let's consider the case we saw earlier. Premises are shown here. We know that everybody loves somebody and everybody loves a lover. Our goal is to show that everybody loves everybody. So we negate this conclusion and add it to our set of premises. Next, we convert to clausal form, leading to the clauses shown here at the bottom. Note the use of the Skolem function in the first clause, and use of Skolem constants in the clause derived from the negated goal. In order to prove the result, we start with our premises. We resolve the clause on line 1 with the clause on line 2 to produce the clause on line 4. And then we resolve the clause on line 4 with the clause on line 3 to produce the empty clause, and thus prove our result. That's it. Slightly more complicated example. Let's once again consider the problem of horses and dogs introduced in an earlier lesson. We know that every horse is faster than every dog. We know some greyhounds are faster than every rabbit. We know that greyhounds are dogs. And we know the relationship of being faster is transitive. We want to prove that horses are faster than rabbits. In order to do this, we're going to negate that desired conclusion. First, we convert the premises to clausal form. As shown here, note the use of the Skolem constant Greg in the second and third clauses, which result from the existential quantifier in the second premise. And similarly, we can convert our negated goal to clausal form as well. Note that to deal with the negated universal quantifiers, we need to add some Skolem constants. In this case, we've chosen to use Harry and Ralph, our prototypical horse and rabbit, assuming that those constants are not already in the language. Okay, we write down our clauses and go to work. First, we resolve the clause on line 2 with the clause on line 4 to derive the fact that Greg is a dog. We resolve the clause on line 6 with the clause on line 1 to derive the clause on line 10. And we resolve these two results to derive the fact that Harry is faster than Greg. Next, we resolve the clause on line 7 with the clause on line 3 to derive the fact that Greg is faster than Ralph. At this point, all we need to do is use transitivity and we're done. We first resolve the clause on line 11 with the transitivity clause on line 5. And then we resolve the clause on line 12 with the result to derive that Harry is faster than Ralph. Finally, we resolve this result with the negated goal clause on line 8 to derive the empty clause. All right, this example shows that resolution is much more focused than Fitch. The added good news is that it's every bit as powerful. In fact, it's possible to derive a conclusion from a set of premises using resolution if and only if it's possible to derive that conclusion using Fitch.